let us discuss how to divide distinct objects into groups. While we can do this question, even with what we learnt in the previous classes, however, there's an error that creeps in, and this session will highlight how to identify it and
we
how to
have
correct.
12 people with us. People, they obviously will be distinct, and we need to divide them into 3 groups. Such that we are talking about, in this case, this is one of the group. It needs to have 3 members. The other group needs to have 4 members, and the third or the final group needs to have 5 members.
So this is given in the question. So in how many ways can 12 people be divided into 3 groups? One group has 3 members, one group has 4 members, one group has 5 members.
If the question was just out of 12 people, we need to form a group of 3 people. It would be 12C 3 ways.
Right, but the question does not stop here. Having formed this, we have to go ahead and form another group of 4 people out over here. So 3 of them have been selected for the first group, or this group here. We are left with 9 people. Out of the 9 people, we need to select a group out over here, which could be done in 9C 4 ways. For each of the previous ways of forming a group, there are further 9C 4 ways of forming the second group. So obviously we would be multiplying. And having formed this group, we are left with 5 people, and the group has to be of 5 members. So that's just one way, but for uniformity, let's write it as 5C 5 ways. So this is the number of ways in which we divide the people into the different groups. This is what I referred to, that you can do it from what we learnt in the previous class. One might question here, and if not, one should question, why do we begin with the group of 3 people? What will happen if I begin with a group of 4 people out over here, forming it? So out of the 12 original people, I first form the group of 4 people, which can be done in 12C 4 ways. Having formed this, 4 of them have been selected out over here. We are left with 8 people. You could form any of them. I'll just take this 5th group. So out of 8 people, form a group of 5, which can be done in 8C 5 ways. 5 of them have been selected. We are left with 3, and the group had to be of 3 people, which would be 3C 3 ways. So which one is the answer? Is it the first one or the second one? And we can write a couple of more expressions like this out over here. Both of them seem to be logically sound, so let's see what do they evaluate to. 12C 3, we know is nothing but 12 into 11 into 10 by 3 factorial. 9C 4 is 9, 8, 7, 6 by 4 factorial. And 5C 5, while it is 1, let me write it in the same way, 5, 4, 3, 2, 1 by 5 factorial. How about the second expression, 3C 3? Okay, let me start with the 12C 4 the way we started. So 12C 4 is going to be 12 into 11 into 10 into 9 by 4 factorial. 8C 5 is going to be 8, 7, 6, 5, 1, 2, 3, 4 and a 4 by 5 factorial. 3C 3, which is just 3, 2, 1 by 3 factorial. If we observe the expressions, the numerator in both the cases is 1 into 2 into 3 into 4, 5, 6, 7 till 12, that is 12 factorial. Even in the second case, it is 1, 2, 3, though the composition of each of them is different, but the eventual numerator becomes 12 factorial. So both of them are valid, and you could start by forming any particular group, the answer does not change. In fact, doing this, you should realize that rather than writing the answer in this way, the final form is going to be just 12 people, so that is a 12 factorial. The group size is 3, 5 and 3, 4 and 5. So divided by 3 factorial, 4 factorial, 5 factorial. This is our answer for this question here. Nothing wrong out over here. So where does the error creep in? The error creeps in when the group sizes are of the same. When the group sizes are same. So let's redo this question. This time the 3 groups need to have equal number of members. There are 12, and so the 3 groups need to have 4 members each. This group here needs to have 4 members, the other group and the
the remaining group needs to have 4 members each. Going by the same logic, we understand that our answer should be 12 factorial by 4 factorial, 4 factorial, 4 factorial. In the previous case, using the logic, the answer we found was correct. However, in this case, this answer would be wrong. And that is what this session is highlighting the error. Why would this go wrong? So 2 things. First, we need to understand why is this wrong and why was it not wrong in the previous case. Second, how do we correct this? Where have I got 12 factorial by 4 factorial, 4 factorial? We have got it from 12C4, form a group of 4 people. From the remaining 8, form a group of 4 people, and the 4 ones left will form the last group, which is 4C4 one ways. When we say 12C4, each and every possible group has been formed. Let's identify the 12 people. Let's number them as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. And let's identify a few ways. One of the way that I'm highlighting here is the group is formed of 1, 3, 5, 7. The group of 4 people could also be formed in a different way. Let's say 2, 4, 6, 8. And I'm highlighting one another way, that is nothing but 9, 10, 11, 12. Each of this is a possible way of forming the group. They would be included in the total number of possibilities 12C4. Having formed the group, there are further 8C4 ways of forming the next one, and then 4C4 of the third one. First group being 1, 3, 5, 7, the leftovers are 2, 4, 6, 8, 9, 10, 11, 12. Every possible way a group is formed, I am just highlighting 2 of them. The group could also be 2, 4, 6, 8. And the remaining ones would form the last group, which are going to be 9, 10, 11, 12. With 1, 3, 5, 7 already selected for the first group, out of the remaining, I could have also formed the second group as 9, 10, 11, 12. 9, 10, 11, 12, which means the third and the remaining group would be of 2, 4, 6, 8 members. And similarly, if the first group was 2, 4, 6, 8, I could have formed the second one as 1, 3, 5, 7 and the third as 9, 10, 11, 12. The second as 9, 10, 11, 12 and the third as 1, 3, 5, 7. And similarly, I would have out in the third case also. Each of this way of forming a group, I have counted it as a distinct way of forming. Whereas if I go and try to express this, this is nothing but the same group. One group is of a member 1, 3, 5, 7. Another group is of the member 2, 4, 6, 8. And the third group is of 9, 10, 11, 12. But I have counted them 6 times out over here differently. Hence, this is going to be wrong. Why does this, what have we done? When we have done this 12C3, 12C4 into 8C4 into 4C4 way, we have ordered the group. So the group, we have ordered them. As in, what do I mean by ordered? We have said there's a first group, there's a second group, and there's a third group. We have made the groups distinct. We have either given it a position, we have given it a name or a designation and something, and we have made the groups distinct. So the first group being 1, 3, 5, 7, second being 2, 4, 6, 8 is different from the first being 2, 4, 6, 8 and second being 1, 3, 5, 7. This is how we have counted. But the question did not mention that the groups have to be ordered. It just said divide them into 3 groups. And hence we have got our answer to be far excess than the correct one. Why did this not happen in the previous case? In the previous case, if you remember, the groups were of size 3, 4 and 5. By the mere nature of they having different number of members, they are distinct. You don't have to really specify whether they are ordered, they are distinct group or they are not distinct group. The members itself make it distinct. And if that is not convincing enough, 12C3 into 3 people are selected, 9C4 ways. Let's just do this.
three ways, three members selected out of 1, 12, 3 is, it could be 1, 2, 3, it could be 1, 3, 5, it could be 2, 4, 6. Never would these groups be ever repeated in the 9C4. Why? Because in the 9C4 we would have 4 different members. So this group can never be formed out over here. And hence there's nothing wrong in the previous example. So how do we correct this now? Correcting it is pretty easy. In fact, the correcting is, if there were n different ways of forming the group, each way of forming the group we have counted it 3 factorial times. Why 3 factorial? There are 3 groups and we have ordered the 3 groups. 3 objects, ordering them is in 3 factorial ways. So the correct way or the answer is, we need to divide this by 3 factorial again. Hope you have got the logic and the error that happens when groups have the same size. And the error is primarily about whether groups are distinguishable or not distinguishable. So this is our answer in this case, the correct answer. If you have got this, let's proceed. Let's do one quick question on the same thing. So we say divide 12 people into 3 groups again. So it's the same thing, such that one group has 6 members, another group has 3 members, and the last group has 3 members each. Well, we see here 6 is definitely a different size compared to these, but the group of 3 members and the third group of 3 members could be indistinguishable. No names are given. So would the answer be 12 factorial, because there are 12 people? One group is of 6 members, divided by 6 factorial, 3 factorial, 3 factorial. Would this be a complete answer? Not really. These 2 groups are indistinguishable as per their member size. We have considered them distinct in this, and so we would have to divide it by 2 factorial this time, because there are only 2 groups which can be double counted among themselves. I repeat, the 2 groups can be arranged among themselves, but it cannot be counted in the position of 6 groups as such. 2 questions and we wind this topic up. The first question is, there are 4 people A, B, C, D. So 4 people A, B, C, D playing a game of bridge. The question is, in how many different ways can they hold hands? By holding hands I mean each one has 13 cards. So in a game of bridge, the 52 cards are divided amongst the 4 people equally. So each one has 13 cards. The 13 cards that they hold is called a hand. So in how many ways can they hold different hands as such? A hand is different if any 2 people have at least 1 card which is different. So the 52 cards, we have to divide them into 4 groups of 13. So the answer should be pretty obvious as 13 factorial into 13 factorial into 13 factorial into 13 factorial. Now the question is, would I be doing anything beyond this? Should I be dividing it by 4 factorial or not? All you have to understand is, do I just have to form groups that are indistinguishable, or do the groups have an order? Do the groups have a name given to it, or so on? Or the other case is, always divide it by this. Always make it an indistinguishable group. Now that you have always made it into an indistinguishable group, do you have 4 different hands and 4 people? So right now what you have is just 4 different groups of 13 cards. But there are 4 people given. It's saying A, B, C, D play a game of bridge, right? So these 4 hands could go to any of the 4 people, which could be done in 4 factorial ways, which eventually means that the 4 factor and 4 factor will cancel out, and you could have ignored it in the first place itself. So this is going to be my final answer here. Why? Because the groups are distinguishable because of the people who are holding the hands. They are an ordered group out over here. However, how would the question look like if we had divide 5 distinct toys into 3 indistinguishable boxes such that one box has 2 toys, one box has 2, and one box has 1 toy. So what is key word here is the boxes are indistinguishable. So when they are indistinguishable boxes, which box does not matter. So we are left with just that I have 5 toys and I need to divide it into 3 groups. What is going to happen of the groups? I don't know, and nothing further as to the story. So we just form the groups and we leave it out over there. So if one would proceed in the logical way and say the first box needs to have 2 toys, which will be 5C 2 ways. Having given 2, the next one needs to have 2 toys. There are 3 left, so 3C 2 ways, and 1 will be left, which is just 1 way. The answer would go wrong. Using the logic of grouping, what is the answer correctly? Let's just use straight grouping. We would have 5 distinct objects, that is 5 factorial ways. One group has a size of 2, so that is a 2 factorial. Another group has a size of 2, which is a 2 factorial. 1 factorial, just for uniformity purpose. Since 2 groups have the same size, in this process we would also have arranged the groups as such, which we should not be doing. So I divide it further by 2 factorial. This will be my answer out of here. You can calculate. The first one is going to boil down to just this expression here, whereas it would ignore the 1 by 2 factorial, and that is why grouping sometimes becomes error prone out.